Or J.
J? Okay.
Hey. Oh wait, no.
Well, Michelle,
I was thinking of 6.
I don't know. I didn't have this done, but everybody said they did. Can you? Okay, here's one thing.
I got G.
How do you get
That's
G?
not right.
Let's go over.
That's not right. Okay, here's one thing that I do want to talk about though. What form is this in? Standard form. Okay. Can you see? What are we looking for? The slope. Can you see the slope when it's in standard form? No, we cannot. You have to convert this, and this is something that I think we're going to get to today, if not today, for sure, next class. You've got to convert this from standard form to slope-intercept form. 2 steps. I'm just going to go quick through it. What's your first step? Minus 5 x. You have to move the x with it on both sides.
Can you do negative 12y equals 5 over negative 12?
I'm not there just yet. Negative 5x plus 24. And then you move the negative 12 by dividing. Dividing. Everything. And so that's where you simplify this down. That becomes positive 5 over 12x. And that is your slope right there. Okay? So you cannot see the slope unless it is in slope-intercept form. And we need to remember how to do this conversion. We've taken a little bit of a break from it, but it's definitely coming back this class and next class. Okay? We got to be able to do that. So, since we have already had this argument about when the test is, let's go over, so y'all don't ask me any more questions. It is Monday, November 13th. Okay? No. We are here on Thursday, 11/2. So we're going to learn about parallel and perpendicular lines. Yes.
Oh, no, I did the other one.
Next week, we're going to continue parallel perpendicular lines, do an exit ticket, then we've got review day. Yes, we have a test on a Monday, but we'll have some time to, I'll probably do a quizzes, warm up again like we've been doing. And then that's the plan for that, okay? So you still have 2 more lessons. You know everything you need to for topic 1. Y'all did a CFU for that last time. We did pretty well with that. Some of y'all, we did some interventions, and I think everyone feels pretty good about that. Parallel perpendicular isn't really that much different either. So, make sure, it's not too much. Okay? All right. But first we need to talk about what that means. So, flip over to page 9. Under where the cell phones are. Go grab one. What's that gold thing? Not. Okay. All right. So what we're talking about today is parallel and perpendicular lines. Have you heard those vocab words before? Parallel? What does that mean?
Up and down.
Straight.
Not necessarily. They can be straight up, or they can be up and down. They can be straight. They what? Okay, something is the same. Are parallel lines ever going to cross? No. So that's something that we do know. So parallel lines are never going to cross. What about perpendicular lines? You know anything about those? They always cross. Do you know what they cross at specifically?
X-axis.
No.
Why?
No. A type of angle that they
90
cross.
degree angle.
They cross at a 90-degree angle. Very good. We don't talk too much about that because that's kind of more geometry's terrain. But there is something in particular that we do need to know about parallel and perpendicular lines. So what I want you to do on these first 2 little problems here with the graphs, I want you to find the slopes of line A and line B, so they're labeled for you, A and B. Over here, same thing, A and B. Find the slopes of each of those, and then we're going to talk about what we noticed about their slopes, and then we're going to come up with our general rule and most important thing that we need to know, Algebra 1, about parallel and perpendicular lines. So calculate those slopes.
How do you find the slope?
y2 minus y1 over x2.
Awesome.
Mm-hmm. So how many points do you need to do that?
2.
2.
So, go do that.
Go do that.
How'd you get that?
All right, what about slope A? What did y'all, slope for line A on the first one? Negative 3 over 2. What about line B?
Same thing.
It is the same thing. Okay? You must have not picked correct points. So let's talk about this. First thing, when it comes to finding slope on graphs, like if I have a picture, I immediately look at which direction my line is going, and then I identify, okay, am I having a positive or a negative based on the direction? Remember, we read a graph like we read a book. We read a sentence, left to right. So line A, I start at the left. Which way is my line going? Down. So I would immediately just put a negative right there. That's like the first thing that I do, is decide when I'm going from a picture, does it need to be positive or negative? We are missing that too much. Too much. Okay? Same thing with line B. Which way is my line going? So I would put a negative. Now, as far as actually getting the number, you still can be using y2 minus y1, x2 minus x1. Y'all are excellent at that. Okay? But if it's from a graph, you have to pick the points out yourself and write them as ordered pairs. And sometimes we don't write our points correctly. So it's kind of good to have two ways. When I do slope from a graph, I count it. I count it out. And some of y'all do too. And I've talked about this. Your slope is your change in y over your change in x. And so I'm counting how I got from point to point. Okay? So let's talk about line A. I always start at the lower point, but it's up to you how you do it. But I like to start at the lower one. What is my change in y when I'm trying to get from point to point? How many did I go up? 1, 2, 3. I went up 3. That is my change in y. That's why there is a 3 in the numerator. What is my change in x? Which way did I go? How many did I go this way? 2. But I went in what direction? Left, which left takes my negative. So positive 3 over negative 2, throw that in your calculator. It simplifies to that. You can put the negative in the very front. Doesn't have to be with a specific number, but you know that guy's got to be negative. So you're just counting from there. Same thing with the other one. I've got my 2 points. I'm starting at my lower point. I notice I change in y. I went 1, 2, 3. 1, 2. So again, I've got that same change in y, same change in x. I don't know how you got that wrong unless you just picked points that were not.
I forgot. I like did both. I did like 1 point on the top and 1 point on the bottom.
Oh, on 2 different lines?
No. On like the when I try to find slope.
Oh, okay. So that's the one thing with when you have a graph, since you have to actually write them as ordered pairs, that does make me a little hesitant with the formula. So I honestly think this is kind of a shortcut, but you're welcome to do it. You just have to make sure that you do it right, okay? And it's your change in y over your change in x.
We have a saying, rise over run.
Yes.
So
Y'all heard that before?
Yeah.
I don't
hopefully
say
you
that
have,
a lot,
but that's
but-
what this is. The change in y is the rise, and the change in x is the run. So it's rise over run. So if that helps you, use it. If it doesn't, use change in y over change in x. That's great.
Or the formula. Like, you got all these options. All these different tools. You pick how you want to use it. Okay, what do we notice about these 2 lines? The slope is the same. Slope is the same. That's a big deal. Anything else about those 2 lines? If you just look at the picture, are they ever going to cross? No. And they will never cross. And then Braden says they are parallel. Okay, so this is our fill in the blank, our vocab word. These lines are parallel. You are correct. There's 2 reasons why. Because we can see they never cross, but what we focus on in Algebra 1 is the fact that the slopes are the same. So the slopes of parallel, P-A-R-A-L-L-E-L, slopes of parallel lines are the same. Same exact number. This is a big deal. Circle it, highlight it, star it.
And that's new information for you. You guys all knew, you're looking up there and going, oh, those lines don't ever touch. That's middle school stuff, and you're saying, well, they don't touch, so they're parallel. The high school version now is, if they have the same slope, then you know they're parallel.
And that's super, super important. Now, let's talk about the y-intercepts. Are the y-intercepts the same between A and B?
No.
No, they're not the same. But they start at different places, but they're doing that same rise and run. Change in y, change in x. And that's why they're never going to cross, because they're moving at the same rate of change every single time from point to point. So we got to know that parallel lines have the same slope, okay? I got a little jingle for you, all right? Parallel lines have the same slope. Okay, y'all repeat. Ready? Parallel lines have the.
Same
You have to like sing it to make it kind of fun. Parallel lines have the same slope. Okay, so we gotta know that because that's a big deal because we're still gonna be writing equations of lines and we always gotta know about that slope. Parallel's the easy one. You just keep it the same. Okay, what about these guys here? These guys cross, correct? Okay, and I'm gonna tell you that they cross at a 90-degree angle. So what kind of lines are these gonna be?
Not parallel.
Not parallel, they're gonna be perpendicular. Okay, let's talk about their slopes. Because again, the high school version is we need to talk about their slopes. What's the slope of line A?
2/1.
2/1. How else can you write that?
2.
Or just 2. I like 2/1 better, but I want to write it both ways because you probably won't see it as 2/1. But again, if you count it, you can see that you went up 2 over 1. Okay?
I did the bottom part of it, I got 4 over 2.
What is 4 over 2 reduced to be?
Well, it's actually 2. It counts by 2s on this one.
Oh, it does?
Yeah.
So that's why it would be 4, because it counts by 2s. Did y'all notice that?
No.
The X and the Y's count by 2s? It really doesn't matter.
Because it's.
still the same time.
Yeah.
I mean, everything's the exact same, so it doesn't matter. But you do need to be a little conscientious of, hey, what are these counting by on the X and the Y axis? Sometimes they count them by 2, sometimes by 1. Usually it's those 2. It's not usually any other number.
Yeah, you definitely should pay more attention than I did, that's for sure. So, Brayden, I put 4 over 2 and alpha y equals. It did simplify it all the way down to 2, okay? But yeah, technically we did go up 4 over 2. Thank you for bringing that to my attention. Plus
Yeah, I
2.
missed it the first time.
I did not notice that yesterday. When you follow the line, though, again, line A, which way is line A going? Up. So the slope should be positive. Again, we want to make those connections. That's going to be test taking strategy for us. What about line B?
2/4.
Hey, coaches.
Line B?
Line
Yeah,
B.
2/4.
No.
What?
What'd you write? Oh, you wrote 2 over 4? Sorry.
What is line B?
Else written.
I did, but like, now that I know.
But what type of 2?
Negative.
Negative 2 over positive 4 because you go down 2 over 4. And then what does that reduce to be? Put negative 2 over 4 and alpha y equals. Negative 1/2. Okay, if you totally miscounted it like I did yesterday, this does reduce to negative 1/2. And again, which direction is this line going? This line's going down. Okay. So are these two slopes the same? No, the slopes are not the same. So slopes are not the same. So they can't be parallel, but we obviously see that the lines cross. Lines cross. And let's talk about these. These are what we call perpendicular lines. And I have a little shortcut for you because like these words to write are like they're hard to spell and they're so long. So I have kind of a shorthand that I'll show you in a minute. But perpendicular lines, the slopes of perpendicular lines are, I'm going to write 2 words and then we're going to talk about what those words mean because they're kind of like the fancy vocabulary. Okay, but I want you to write it down. Opposite is the first word, and we're going to talk about that. The next word is reciprocal. Opposite reciprocals.
You write it down.
Have you heard either of those words before? You've heard of opposite. Okay, what does it mean by opposite?
Like,
Different.
no.
These are 2 examples for you. How could you guys talk about these being opposite?
Oh, it's the opposite.
One is a fraction.
Opposite sign, okay? One is a fraction, one is a whole number. But opposite, when I talk about opposite with this, I am talking about opposite sign. As in, one of them is positive, one of them is negative, okay? So opposite sign. Reciprocals, have you heard that word before? Anybody know what that means? It has to do with the numbers. Do what?
I think it's like
Not the same.
when the numbers in the fraction they switch it.
Exactly. That's exactly what it is. Reciprocals are
Flip it.
a flipped fraction. So reciprocals are flipped fractions.
Well, we write that down.
I would. This is kind of this is the fancy way. This is like what we can sum it up to be. So change the sign and flip
Change
the fraction. Okay? So if you look at our fractions, so Zane said 2 over 1. And I said, I'd rather it be a fraction. But they don't normally do that. They normally simplify it all the way down to 2. So we would go in and we'd write 2 over 1 because that's going to help us. If I flip 2 over 1, what do I get? I just flip it. Flip the fraction. 1 over 2. So do you see how I have a 1 here and a 2 here? How these guys are reciprocals because they're flipped over. But then they're also opposite signs. This one's positive, this one's negative. That's the way the slopes of perpendicular lines work, okay? The jingle doesn't sound as good, but I normally will say, okay, perpendicular lines you flip and change. Flip the fraction, change the sign, okay? That's what we're saying. But that's a lot more words than flip and change. And then Roman came up with something yesterday. I forgot what it was already, though. But whatever it takes, you got to know.
It wasn't as good as flip and change.
Flip and change makes it kind of easy, okay? But you're flipping the fraction and changing the sign. Those two things have to be true. So let's play a little game real quick, okay? What is the... Did you have a question?
Yeah. If it's 2 over 1, can you put down the star and then count it as 2?
I would imagine so, but I honestly don't know. But I would imagine. I don't know. We can kind of play around with that and see. Because it is the same. But I feel like if it was multiple choice, they definitely would just put 2. But a type in one,
I bet they take
I think they
I
would
bet they
take
take
that.
But your multiple choice, like Ms. McCarthy just said, you won't see one that says 2 over 1.
You will not.
You'll just see 2x.
You will not. Okay? So let's make sure we understand the definition of reciprocal real quick. Remember, reciprocal is flip fraction. So if your original fraction is 5 over 7. 5 over 7. What's the reciprocal of that? 7 over 5. Okay? If your original number is 8. 8. 1 over 8. Very good. Very good. Okay? All right. So knowing now that we know this, parallel lines are the same. Perpendicular lines, you change the sign, flip the fraction, flip and change. That's kind of how we say it. Let's fill these out real quick. And then honestly, this is really the only thing that's like truly new today. Okay? But you're going to see how we put this in and connect it with the other stuff we've been doing. So here's 2 slopes. Negative 2/3 and negative 2/3. Which word are you going to circle when you compare these 2 slopes? Why? Because they're the same. They are pretty easy. What about a slope of 2 and a slope of negative 1 over 2? They're flipped and they're changed. Flipped and changed.
Flipped and reciprocals and opposite.
Opposite reciprocals. Reciprocals that are opposite signs. However you want to say it. Again, that's just a lot of words. It's a lot of words. Okay? All right. M equals 2/5. If they give you an M, what are they giving you? What does M stand for? All the time. Slope. So, slope is 2/5. Tell me a parallel slope. Parallel lines have the... So, I'm just going to write 2/5. Easy. All right. Perpendicular lines, I flip and change.
5 over 2.
What kind of 5 over 2? Okay, so flip it, then change it. Okay, change it, then flip it. Why would it be negative? Because the original one is positive.
It's got to be the opposite. If
That'd
that's
be
positive, it
opposite
becomes negative.
reciprocal. All right, what about this? Y equals 5x minus 7. What's your slope there?
5.
How do you know?
Because it has an X right next to it.
Because it has an x right next to it. When it's in, what form is this in?
Slope.
Slope intercept. Very good. Okay, 5. If parallel will be 5. Perpendicular.
Do me a favor too. Don't write 5x.
Oh,
Right?
yeah.
It's
Slope
just
is a
5.
number.
It's just a number next to x.
Perpendicular is negative 1 over 5. Yeah, please do not write an x next to it. That's how you identify it in the equation, but when you talk about slope, slope is a number. And then if it helps you guys to put that as 5 over 1 so you can see how the fraction's working, that's kind of tricky to me. When it comes to being perpendicular, that's kind of tricky. Okay? So you are going to have some questions like this on your homework that are just straightforward. Tell me the parallel slope, tell me the perpendicular slope. You're just writing same number, flipped, and changed to number. Okay? But here's why we actually are going to do this, is we're going to get to problems that say like, I want you to write me an equation of a line that is parallel to this guy, but goes through this point. Or I want you to write me an equation that's perpendicular to this guy, but goes through this point. So we have to kind of put all that knowledge together and go over what we've been going. So we wrote some steps, but this is kind of the flow. Your problems today are very structured. They kind of have little like stopping points. What's the key word? What's the slope? What's the this slope? Like it's kind of like scaffolded for you so that way you can kind of like see how the process works. But eventually, next class, and when we get to the tests and stuff, you're not going to have any of the structure there. So we kind of got to know these steps. So we need to start by figuring out what slope did they give us. Okay, they're going to give us an equation of a line that we want to be parallel or perpendicular to. So we got to find that slope. We got to pay attention to which word we're talking about. Parallel or perpendicular. Right here on step 2, I want to show you the shorthand for parallel. Y'all with me right here? Parallel, you can write 2 vertical lines like that. That's a shorthand for parallel. I use this a lot because this is a hard word to spell. Perpendicular is an upside down capital T.
Carrie's dog and eggs.
No. You cannot. You can either draw this, or you can draw this, or you can write it all the way out. Those are your options.
You might see those parallels slanted sometimes, more than just straight up and down. You might see them slanted. And then when I think of it about the capital T, what do we say about perpendicular lines? They have what kind of angle?
90.
A 90-degree angle. So you can see, just when McCartney just drew it, though the upside down T creates a 90-degree angle.
Mm-hmm.
So if that helps you, just go ahead and throw your little box in there. That means 90 degrees.
Yeah.
Is what that means.
Or you've seen them this way,
Yeah.
like that.
Yeah.
Okay.
So either way, you'll see the
Just short. It's just shorthand, okay? Just to make like we don't have to write as much. But you got to really. We're always going to be circling that word because that word's going to be everything. And then we're going to sing our song. Parallel lines have the same slope. Perpendicular lines you flip and change. Change and flip. I think flip and change sounds better.
flip
I
and
don't know.
change.
Flip and change.
Sounds way better.
Okay, so then once you figure out what type you're talking about, you got to find that slope, the parallel slope or the perpendicular slope. Find the point. We're going to go to point slope, and then we're going to convert. That is the flow. That's a lot of words. A lot of these steps are quick. We're going to jump in, and we're going to do that here. Fill this out real quick. Parallel lines have the same slope. Perpendicular lines that are flipped fractions. That's fine. And change sign. If you said opposite reciprocal, totally fine. That is the more formal mathy way. Okay? Opposite reciprocals. You sound like super smart talking about that. All right, so let's see these in action. Okay, we're going to do a couple of these. Today we're just really going to stop in point slope form. Just so we can get the idea. And the next class, again, we're going to kind of like take it all the way, go through the complete process. We just want to baby step through it. So these are what the problems will look like. Again, I put a lot of stuff on here for you. A lot of stuff to help us reason through it. Okay? That's not going to be there on the test. So we're starting from like, beginner. Okay? All right, number 1. Let's look at number 1. I want to do number 1 and number 4 with you. And then I'm going to let you guys try the other 2 on your own. So number 1, write an equation in what form? Point slope form. So we're just going to point slope today. Remember where that is. Find it on your chart.
Put it in point slope form.
Do what?
You still have to put it in point slope.
Boo-hoo. All right, point slope form of a line that passes through -4, 2 and is what? Parallel lines have the, I'm going to write that down, same slope. I'm going to have this drilled into my brain. And you're going to hear my voice saying that on April 23rd when you're taking the STAR test. I bet you will see it. Okay? Okay? So parallel, yes. All right, parallel 2. Y equals 3/4. Hey, doesn't matter. Okay, doesn't matter. Y equals 3/4 x minus 2. So here's what they give us. They gave us a point. We need that point. They gave us an equation of a line, and they told us that we want to be parallel to it. You need to know how to sort through this information. Which one are we looking at? Parallel or perpendicular? Parallel. Okay? What is the slope of the line that they told us about? Y equals 3/4 x minus 2. What is the given slope there? How did you know that it was 3/4?
So there's an X right next to it.
Because there's an X right next to it, and that line is in what form? Y equals. No. This line that I drew the arrow to, what form is this in?
That's important. No, not.
That's in slope intercept. So slope is right next to X. I need y'all to emphasize that because sometimes they're not in slope intercept form. That's where we're going. Okay? So the slope of the given line is 3/4. Okay? I don't want to, the new slope that I'm using is the parallel slope. What is parallel slope to 3/4? Parallel lines have the, so I'm going to write down again 3/4. And this is the one that I'm going to use for my point slope form. This is my M, my parallel M. What point do we want our parallel line to go through?
4, -4, 2.
-4, 2. This is the point that we're going to use. So do you see what we have? We have a point. We have a slope. We're going to go to point slope form. This is our x1, our y1. This is not new. The only thing new is we had to steal the slope, keep it the same, plug it in. So here we go. Point slope form is, on my chart, y minus y1 equals m times x minus x1. Y value of the point that I want to go through is what kind of 2? So I'm going to write a
Y minus 2
equals, what's my parallel m? X.
plus
X plus 4.
4.
Excellent. And we're good. This is as far as we're going today.
Oh, this. Wait, that's it?
That's it. That's it.
No more questions?
Huh?
No more questions?
No. But we're done with this question. Okay?
Oh, we didn't got solve anything.
Not today. We're going to convert it next class. Okay? All right.
How do you, put it in like,
Get it to slope intercept form. But again, we've been doing that for weeks. Okay, let's look at number 4. Number 4, I think, is a little bit trickier. And I found a star question. It was kind of like this last year. All right? So we're going to do 4. So now you've done 1 in words. We're going to do 1 with the graph. And then you're going to try 2 on your own. All right, here we go. We're going to write an equation. I'm on number 4. What form are we stopping in on number 4? Point slope. That is, what's my word here? Perpendicular. All right, I'm going to make a little note. What do we know about perpendicular slopes? Slopes. Flipped and changed. Flipped and changed. Okay? Perpendicular to this line. They didn't give us an equation. They gave us this line. And we need to go through the point 1, -5. All right. What word am I going to circle here? What word am I talking about? Parallel or perpendicular? Perpendicular. I need to find the slope of the original guy, which on number 1, they gave us an equation and we just copied down the number. But on this one, we gave you a graph. We don't like graphs. Okay? So what is the slope of this graph? First thing, which direction is the line going? Down. So the slope's got to be negative. All right, look how nice it is. We put some nice pretty points on there for you. Let's go the y-intercept to the one right next to it. Here to here. What is my change in y? 2. I got the negative.
2 over 1.
And then my change in x is 1. So this is my original slope. -2 over 1. I'm going to keep it like that.
I just put 2.
We only went down 2.
I just put -2.
-2 is fine. Or -2. Okay. What kind of slope do we want? It says new slope, but what kind of slope do we want?
Positive slope.
We want a perpendicular slope. So we got to flip it and change it. So you're right. It is going to be positive because the original guy is negative. So positive
2.
1
Under 2.
over 2. 1 over 2. Do you have to put the positive sign? No, I would just put 1 over 2. But sometimes I like to write that sign there. But you got to flip the fraction, Flip 1 and 2, make it positive. So our perpendicular slope is 1/2. All right, what point do we want to go through? 1,
Negative 5.
1, -5. That was in the problem.
Okay, now it's easy.
Okay, so we're using this slope, this point, perpendicular slope, given point, point slope form.
Y minus 5 plus 5 equals 1/2 x minus 1.
Very good. Very good. Okay, why is it y plus 5?
Because it's a negative 5.
Because it's a -5. Okay, all right, I want you to try 2 and 3 on your own. What you got?
I got
Hold
Y
on.
minus
Parallel, hold on, we're gonna go through the steps. Parallel or perpendicular?
Perpendicular.
Perpendicular. What was the given slope?
4
4 over 3.
4 over 3. This one was nice. When they give you an equation in slope intercept form, we're saying like, yes, thank you. So what is a perpendicular slope to that?
Negative 3
Negative
over 4.
3.
Flip it, change it. Very good. Okay? And y'all, these problems, they involve reading. Okay? You have to read through these words. You are going to have to do what I'm doing without any of that being there. Your problems on your test are going to be like this. And then it's going to have an answer blank. It's not going to ask you all those questions. So this is the process that our brains are going through on a problem like this. Okay?
You say like if it's perpendicular.
It will, yeah, the word will be there, but like that's up to you to like make sure you're writing down the perpendicular slope and you're writing down the point. Like you got to sift through all that information and take it all out, okay? But we're not going to have these little like questions for you to fill out. It's just going to be like question, what's your answer? We'll get there, but that's the goal. All right, what point are we trying to go through?
4 over 2.
4,
4.
2.
4, 2.
So what is our point slope form?
Y minus 2 equals negative 3 4.
X minus 4.
Beautiful. Good?
Yep.
All right, the graph one. Again, these were, I haven't seen a question like these graph ones until last year's STAR test. So, this is new stuff. All right, we've got, what's our keyword?
Parallel.
Parallel. We want to be parallel to this line. What slope did y'all get of that line?
2.
2 over 1.
2 over 1, which simplifies to 2, but we honestly like it better to be 2 over 1, don't we?
Yeah.
Yeah.
And if you're having a tough time, do what Miss McCartney did and draw up and over. Like, draw that. And then put like a 2 out next to it when you count it, like to the left of that, like Miss McCartney has been doing, where she put that +2 and a +1. Because I'm going up 2 to the right 1. Those are both positive movements.
And again, which way is the line going?
Positive.
Up. So it should be positive, okay? All right, so we want a parallel slope. What slope are we going to use?
2.
2. That's the slope we're going to use. Keep it the same, okay? What's the point we're going through?
Negative 2, comma 3.
What's our point slope form?
Y minus 3 equals 2x
plus
4,
Very
2
good.
plus 2.
Very good. All right, see, you see how really there's only one new thing today is getting the parallel perpendicular slope. Okay, I'll make you a deal. We're going to go to the next page. We're going to do the first 2 problems. I think one's parallel, one's perpendicular. And then we're not going to do 3 and 4. Okay, you want to put a big X through 3 and 4? Would that make you like feel good to do that?
And then we had to.
And then we're going to do our homework. Yes, that's what we're going to do. Okay? I'm only going to make you do 1 and 2 right now because these are going to take a little bit more. And let's talk about why. We're trying to write an equation of a line in, again, today we're stopping in point slope form. Next class we'll take it all the way, but that skill's not new. That goes through the point 4, -8, and is, what's our key word? But look at the equation that I gave you. I did not put it in slope intercept form. I put it in standard form. Actually, with star. These are star. So why is this problem harder? Got to find the slope. Good. Well, let's review. What word are we going to circle? Parallel. All right. So this guy is not in slope intercept form. So I put this steps at the top for you. And we did this on that warm-up problem yesterday or today, I don't know. And how to convert it. And that's why we gave you a little bit of space right here. Y'all, they do this on the STAR like more often than not. It is so mean to, in my opinion, I think it's so mean to make you have to convert it and then do all this stuff, but this is what they do, okay? So let's go through our steps. Step is to move your x term. So how am I going to move a positive 6x?
Minus 6x.
Minus 6x. And what I do to one side, I have to do to the other side. I'm going to kind of write within that problem. Are y'all okay with that? So then that's going to go away. What kind of y am I going to bring down? Positive what? 3y equals, I cannot combine. Cannot combine. So I write them side by side. Negative 6x plus 15. Remember, those are not like terms. They do not go together. You get two terms. Could you do 15 minus 6x? Sure. Okay, but you got to know where the slope goes with it. Am I in slope intercept form now? No. So what do I do now? Everything divides by 3. And I'm going to alpha y equals that. Completely forgot about that. This is a big deal. We're going to be doing this in our next unit as well. It's not going away. Which really, what's the only thing that you really need from this equation? The slope, the number in front of the x. That's really the only thing you need there. So the slope-intercept form of the line that they gave us was y equals negative 2x plus 5. Okay? So all that work, and we just scratched the surface of this problem. What do I need to take from that line? That's all I need. What is the slope of that line? All right, now take it back. Are we all okay with that? That step is, it takes a minute. Now we got to bring it back to what's the problem actually asking. We want another line that is what? What's our word? Parallel lines have the... So the slope that we're going to use, our parallel slope is... Same slope. All that work just to get that little piece of information. What point do we got to go through?
4.
Your point and your slope. Yes.
Why is it a negative 6?
Why is it a negative 6 up here?
Minus 6.
Because it was a positive 6x on this side, so when I moved it over, I had to change the sign to move it over. Okay? All right, my point slope form. Y, what? Plus 8. Why is it a plus 8? Because it's a negative in the point. What's my parallel slope? Same slope.
Negative 2.
You put minus 6 right here, and again, you should put minus 6x. Whatever I do to one side, for some reason you put
Okay.
plus. That should be minus, and you need to.
All right, so this second problem that we're going to do is really similar, but what's different?
It's perpendicular.
It's perpendicular. We're going in point slope form. What did I give you? What line did I give you? What form is that line in? Standard. So can we see the slope when it's in standard form? No, no, no. All right, we got to change
Divided
it.
by a negative 2, so you have to change the sign.
Yes, yes. Well, if it was an inequality, you'd have to flip, but yeah. Okay, so Heidi, what am I going to do with that 8x?
Move it to 10, so minus 1.
Subtract it over here, subtract it over here. So I'm going to have that negative in front. Now, be careful. What's in front of that 2y?
A negative.
A negative sign. You've got to take that with it. So I have negative 8x plus 10. And then I'm going to divide everything by what kind of 2?
Negative 2.
So be careful when you're typing that in your calculator. So that's going to get us...
And if I'm doing it parallel, what's the new slope going to be?
Is that what y'all got for your slope-intercept form?
Yeah.
Okay. So all that work, what's the one thing that we need from that slope-intercept form? The slope. The slope of that is
4.
4, but what kind of slope do we need? Perpendicular. So we got to flip it. Remember, this is the same thing as 4 over 1. So when we flip it, 1 over 4, change it,
So which slope would you use?
you have to use the perpendicular one. You see how it says new slope?
Yeah.
You got to use that one.
Okay.
Okay? So it's like these things at the very beginning are not really, we're just like, we need to know them, but we don't use them in our form. What point? 4, -8. Oh, again, we use the same point. So y plus 8, 1/4 x minus 4. Okay? So, honestly, this is really all the new stuff in this whole unit. The only thing that we're going to do next class is we're going to keep reviewing this. We're going to gradually take all those steps away. But then what we're really going to get to is what? We're not just going to stop in point slope form. We're going to go slope-intercept form. Okay? So not a whole lot of new stuff, but I imagine over the weekend we'll need a nice, pretty review over that when we come back. Okay? Let's get your practice packet out. At this point, you guys should all be done with 5.1 to 5.2, and we've all checked it. Like, we spent a lot of time last class doing that. 5.3 starts at the bottom here, okay? The first two problems are literally just saying what a parallel and perpendicular slope are. That's it. That's quick. Okay, flip over. Then you have 5.3. You've got 2 more questions up here. It's not as structured. I have his up here. I'm using his.
Okay.
So it's asking you, giving you a problem. It's asking you to stop in point slope form on 3 and 4 right here. Y'all see that? All right, I want you to look at 5 and 6. There's a graph right here. There's a graph right here. Are y'all looking at this one? Everyone looking at that? Okay, so you need to find the slope of this graph, and one of them is going to be a parallel, one of them is going to be a perpendicular, but there's no point, so I'm going to tell you what the point is. Goes through.
Well, they say goes through on our test.
Yeah, it will say something. Passes through, goes through, contains the point. This is how they did it on STAR. Goes through point P. Okay? And then they had a graph. We're about to put it on there. They had a graph on point P. The point that I picked on my answer key was -3, +2. -3, +2. But they didn't tell you that it was -3, +2. They just put it on the graph like I did. So I want you to practice with that. So they want a parallel to this line through point P. They want a perpendicular to this line through point P. That's what the question wants. Does that make sense? Does that make sense through there? Okay. And then everything today is in point slope form. And those are your only problems. So it's really just 1, 2, 3, 4, 5, 6. We're done. The very last page we're going to do next class. Okay. So that's it. If y'all finish, because we still have 30 minutes, 25 minutes. If y'all finish, we can check. But then that's where we are. That's all.